Hello, my fellow learners. We are now here again to the next problem that I have posted in our page, and that is find the limit if it is exists. Hope you enjoy it. Okay, here it goes. So the given problem that we have is for number one is limit of 2x cubed plus 125 all over 3x plus 5 as x approaches negative 5/3. And the other one, which is number 2, we have limit of x squared plus 8x plus 15 all over x squared plus 6x plus 5 quantity raised to 5 as x approaches negative 5. For number 3, we have limit of 7t plus 3 all over 5t plus 1 as t approaches positive infinity. And for number 4, we have limit of 16t to the 5 minus 15t squared plus 3t plus 7 all over 8t to the 5 plus 11t squared minus 4t plus 2 as t approaches positive infinity. So we have now our process in dealing with this 4 set of problems. For number 1, we have given the limit of 2x cubed plus 125 all over 3x plus 5 as x approaches negative 5/3. So the solution must be, the first thing that we should do for this is we are going to have to factor out whatever the expression in both numerator and denominator that we have, if necessary. So since in the given numerator can be factored by quantity 3x plus 5 times the quantity of 9x squared minus 15x plus 25, since the given two binomial terms is a perfect cube. So the perfect cube of 27x squared cube is 3x, and the perfect cube of 125 is 5. So we have now the separation of the term is the addition symbol, so we have to copy the plus sign. So what we have in the next factor is we're going to get first the square of the first term of the first factor, which is 3x. So the square of 3x is 9x squared. Then in order for us to get the second term, so we're going to get the product of 3x and 5. So the product now of that would be 15x. Then take the opposite of it. So 15x, the opposite of 15x is negative 15x. So we have to copy that one. And then the last term is we have to square the second term of the first factor, which is 5. So the square of 5 is 25. So we have here 25. Then all over 3x plus 5, since the 3x plus 5 cannot be factored anymore as x approaches negative 5/3. So as you can see, we have here the 3x plus 5 in the numerator and 3x plus 5 in the denominator. So we are going to cancel that one by means of the existence of multiplicative identity. So we have now the limit of quantity 3x plus 5 times the quantity of 9x squared minus 15x plus 25 all over 3x plus 5 as x approaches to negative 5/3, cancelled the 3x plus 5. So we have now left here the limit of quantity 9x squared minus 15x plus 25 as x approaches negative 5/3. After which, the next thing that we should do is we're going to substitute the value of x, which is negative 5/3. Since our given x is just approaches negative 5/3, then we cannot able to make it 0 as our denominator. The value of denominator will be 0. So we have now replaced everything after the cancellation. So we have 9 times the quantity of negative 5/3 quantity squared minus 15 times the quantity of negative 5/3 plus 25. So we have 9 times the square of negative 5/3, which is 25 over 9, minus 15 times the quantity of negative 5 thirds plus 25. So we have now cancelled the negative 15 and 3. So so we could now have 5 times 5. Then another thing is we're going to also to cancel the 9 both numerator and denominator, both term in the expression of the first term that we have. So we could now have 25 plus 25 because 5 times 5 is 25, then copy the 25 for the last term. So we could now have 75. So we could now conclude that the limit of 27x cubed plus 125 all over 3x plus 5 is, as x approaches to negative 5 thirds, is equal to 75. That would be our given problem, or the answer to our given problem for number 1. So let's proceed for number 2. So let's recall our given problem for number 2. We have limit of the quantity x squared plus 8x plus 15 all over x squared plus 6x plus 5 raised to 5 as x approaches negative 5. So the solution will be, the first thing that we should do for this is we're going to manipulate everything. If necessary, we could get its factor before we could apply the limit. So since the given expression in the numerator can be factored by quantity x plus 3 times the quantity of x plus 5, same also with the denominator, the factor of x squared plus 6x plus 5 is x plus 1 times x plus 5. So I assume already that you are aware of how to factor. If you don't know how to factor, just go with my other videos on how to factor the certain algebraic expression with regards to quadratic trinomial expression. So we have now raised to 5 as x approaches negative 5. So as we can see that the x plus 5 on both numerator and denominator can be cancelled because they are, through the multiplicative identity became 1. So we have now limit of the quantity x plus 3, the cancelled out part of x plus 5 times the x plus 5 all over x plus 1 times the quantity of x plus 5 raised to 5 as x approaches negative 5. Then after which, since we could now able to cancel the certain part of the expression in the given problem, so we could now apply the limit by means of replacing the value of x to become negative 5. So negative 5 plus 3 all over x plus 1. Why? Because we only have left here in our numerator x plus 3. Then the denominator is x plus 1. So we have now that one. So as we evaluated here, so the negative 5 plus 3, it became negative 2. Then the negative 5 plus 1 is negative 4. So since negative 2 and negative 4 can be simplified through dividing both numerator and denominator by negative 2, so it became now 1/2. So 1/2 raised to 1/5, and that is 1 over 32. So we could now say that the answer of the given problem number 2, wherein the given expression, the given problem is this limit of x squared plus 8x plus 15 all over 8x squared plus 6x plus 5 quantity raised to 5 as x approaches negative 5 is equal to 1 over 32. So let's proceed now to problem number 3. The given problem number 3 is limit of 7t plus 3 all over 5t plus 1 as t approaches positive infinity. So as we apply the solution or working with this, since the highest degree of the variable t that we have is t, so multiply both numerator and denominator by 1 over t. So as you can see in the given solution, as you notice that we have now 1 over t both numerator and denominator. So after that is we're going to distribute this 1 over t to 7t, then 1 over t to 3, as well as here 1 over t to 5t, then 1 over t times 1. So we could now have 7t times 1 over t is 7, 3 times 1 over t is 3 over t, then we have also in the denominator 5t times 1 over t is 5 plus 1 over t. So we have now limit of quantity 7 plus 3 over t all over 5 plus 1 over t as t approaches to positive infinity. So with that, the limit of the constant is still constant. So 7 plus 3 over the limit of 3 over t is 0. Then copy the 5, then 5, then the limit of 1 over t is 0. So we could now have 7 over 5 as the value. So as we apply the limit of the given problem number 3, which is a limit of 7t plus 3 all over 5t plus 1 as t approaches to positive infinity is 7 over 5. Okay, so let's proceed now to number 4. So the given problem for number 4 is we have 16t to the 5 minus 15t squared plus 3t plus 7 all over 8t to the 5 plus 11t squared minus 4t plus 2 as t approaches positive infinity. So as you can see here, the highest degree of the exponent t, the variable t, is 5. So as you can see in the solution here, we could multiply now the both numerator and denominator by 1 over t raised to 5. So we could now have 1 over t raised to the 5 for both numerator and denominator. So through that, after which is we're going to distribute that 1 over t raised to 5 to 16t raised to 5. Then we have negative 15t to the squared, t squared rather, plus 3t, and then times 7 plus, then same as well in the denominator, distribute. Then the distribution property here, each operation is multiplication, so we are going to multiply everything there. So we can now have 16t to the 5 times 1 over t to the 5 is 16. So next is 15t squared all over times 1 over t to the 5 is negative 15 over t cubed, because the exponent of the denominator is more than the exponent of the numerator, so we are going to subtract the denominator. So we have 5 minus 2, and that is t cubed. Then 3t times 1 over t to the 5 is 3t raised to 4. Then plus 7t raised to 5, 7 over t raised to 5. Same as with here. So 8t to the 5 cancel. So we could now have 8. Then 5 minus 2, so we have 11 over t cubed. Then we have minus 4 over t to the 4, then 2 over t to the 5. So after which, since we could now have everything as the denominator goes for the variable t, so applying now the limit. So the limit of the constant is still constant, so the limit of 16 is 16, and the limit of 15 of negative 15 over t cubed as t approaches to positive infinity is 0. The limit 3 over t to the 4 as t approaches to positive infinity is still 0. 7 over t to the 5, its limit is 0. All over, we have 8 plus 0 plus minus 0 plus 0. So after which, we could now have 16 over 8, and that is 2. So we can now say that the limit of the given problem number 4 is equal to 2, wherein the given limit problem is limit of 16t to the 5 minus 15t squared plus 3t plus 7 all over 8t to the 5 plus 11t squared minus 4t plus 2 as t approaches positive infinity is equal to 2. So it's now the finishing part of our given 4 examples. So I hope you already learn with this process, and I hope if you're going to have your answer previously, let us compare what have we done, or if you have some question or doubts with your answer, this is now the chance for you to identify where you can get your problem or where can you get your process wrong. So thank you and see you around for the next video lesson. Bye.